everyone. I hope that you're all doing well and that you and your families are healthy. As you can see, we are practicing safe social distancing here in the lab. I'm the only one here. And we're also very diligent about hand sanitizing. Let's see here. Empty. Last one. Okay, so please bear with us for this video and the multiple videos that are going to follow for the rest of the semester. We're doing the best we can with a limited period of time and very limited experience making videos. And we're probably going to have multiple videos per lab session. But overall, the amount of time you spend watching will be less than a normal lab session because you won't make any mistakes that we have to correct. As some of you might know, one reason that my movie career never took off is that I can't memorize dialogue, so I have to read from a screen. But luckily, I found this handy clipboard in the lab after our last lab session, so I hope it's okay if I borrow it. All right, thanks, Adrian. Okay, time to sanitize again. This lab session is called the Airflow Demonstration Unit, and this is the small wind tunnel behind me, and it's got a number of test sections where we'll be taking some pressure measurements, just as you've already done in other lab sessions to date. All nice and clean now. The objective of this lab session is to learn more about air flowing in an airway, and primarily to learn about shock loss. In any ventilation system, pressure supplied by a fan or fans is lost either to friction losses or to shock losses. Shock losses are usually smaller than friction losses, but they can represent 10 to 30% of the total pressure loss in a mine, and that can be significant. As we will discuss, there are things that you, as a ventilation engineer, can influence in order to minimize shock losses. During our last lab session, we learned about friction losses in the friction factor wind tunnel over an LMR 155. Friction losses are the result of flow losing energy due to contact with the boundaries of an airway, and the smoother the boundaries, the less energy is lost. Shock loss is different. Shock loss occurs whenever airflow undergoes change, either in direction or velocity. Typically, change in an airway involves bends, contractions, expansions, or some variation of those, or out-and-out obstructions, as we saw with that simulated mine train in the friction factor wind tunnel. It's fairly easy to imagine a sharp bend causing a loss of energy, but it might be surprising that just changing the area of an airway will also create an energy loss. This is true both for a decrease in area, as you might expect, but also for an increase in flow area. One way to loosely think about shock loss is that in order to change the direction or velocity of an airflow, a force needs to be exerted on the airflow, and that requires energy, and the energy is supplied by a resulting loss in pressure. In some cases, changes in an airflow can cause some of the air to flow in the wrong direction, and it requires even more energy to get that air flowing back in the intended direction. So shock loss is independent from, but in addition to, friction loss, which again occurs at an airway boundary. Okay, we're going to take a quick tour of the airflow demonstration unit, and then we will look at the handout for this lab, which hopefully you've received by now via email. And we'll look at some of the theoretical equations that you will need, and then we'll look at the experimental test sections in detail while we take measurements. We'll do that one at a time. But first, time to sanitize again.